Hi, welcome to my channel. This is Srini Sripati. In my previous video, I showed the Teams bot SQL Assistant and demoed how GPT models SQL generation capability can be used in a business application by creating user workflows with the help of Microsoft SemanticKernel. I also did a little code walkthrough in it. If you didn't watch it, the link is in the description. In this video, I'm going to deep dive into the architecture of this bot and prompt flow between the bot or semantic kernel and the GPT-4 model. If you did not watch my previous video, here is the small introduction. What is this bot? It is a GPT-4 LLM powered Teams bot that generates SQL queries from user requests given in the natural language form. It runs the generated queries and shows the query results on the chat window or exports to an Excel file and emails the results with the exported Excel file as an attachment optionally. It is built using Microsoft Bot Framework and Semantic Kernel SDK. The Bot Framework is used to build bots for different apps like Teams, Slack, Facebook Messenger, WhatsApp, etc. Semantic Kernel is an AI orchestration framework that is used to build workflows or agents or co-pilots with models from OpenAI, Azure OpenAI, Hugging Face, and many more. I'm not going into these deeply here. I gave the links in the description for you to go through. Let's see the architecture. The bot is actually an ASP.NET Core web application with one API endpoint, API/messages. We need to implement an interface from bot framework, iBot, if we want to have custom message processing. So here it is the semantic kernel iBot class that implements iBot interface, which processes the user messages. In this case, the custom processing is creating a planner and calling the functions based on the plan to complete the user request. The kernel object is created during startup and it is made available to the other classes with dependency injection. When a message is received from user, the planner creates a prompt with the user request or goal, and the functions loaded into the kernel plugins will be sent to the LLM, which is GPT-4. I will talk about the prompt flow in a while. The bot app also has different support classes and a manifest for installation in Teams. The support classes are for connecting and retrieving results from database, exporting to Excel, sending emails. This diagram also shows the external services that the bot connects to. Azure OpenAI for Gen AI model, which is GPT-4 here, a database where the data is stored and where the queries are run to pull the data from. MS Graph to send emails and application insights to store the logs and metrics. Let's see the prompt flow. When user sends a message to the bot, semantic kernel creates the prompt to generate a plan to fulfill the user requested goal. I use the function calling stepwise planner of semantic kernel, which has a default generate plan prompt. We can customize this prompt if the default one doesn't work for our requirements. Semantic kernel includes all the functions loaded into the kernel object. In the generate plan prompt, appends the user message to it and sends it to the model. This is the chat history between SK and GPT-4 pulled from logs. The first step is the generate plan prompt that has all the functions loaded into the kernel object and the user message. The model replies with the completion that has the generated plan. This contains information like what functions should be called and in which order to fulfill the user requested goal. This is the generated plan from GPT-4 for completing the goal, which is get top 5 sold products in last year and send an email to my manager. Upon receiving the plan, SK sends another prompt to perform next step in the plan. Model responds with the completion text that has the next function to be called in the plan with the arguments. It continues back and forth till all the functions in the plan are executed. So it needs get tables and get schema functions to be called so that the tables and schema details are pulled and sent to the model. Model will use that information to generate the SQL queries. Once it reaches the last function call, the model sends the final answer, that is the summary of all the function outputs in the plan. I added the chat history text file to the repository. Go through it if you want to see the complete prompt flow between the semantic kernel and the model GPT-4. The Gen AI models will definitely replace some of the core skills or intelligence of humans, like the SQL query generation in this case. But to make use of this capability in a business application, we need to create workflows, and that is what the semantic kernel and other AI orchestration tools like LangChain provide. We just need to implement all the functions and load them into the kernel. Everything is taken care behind the scenes by semantic kernel. Hope you like this video. If you have any questions, post your questions in the comment section. Please share it and subscribe my channel for more such videos. Bye. See you in my next video. Thank you.